this video, we'll be looking at security testing. Okay, testing involves good software engineering principles regarding testing. To be able to test your software in a good way, it involves security mindset, principles, and consideration. So nowadays, a lot of frameworks will provide you about what you need to test, but also it is a good idea to get a lot of hands-on exercise to understand what different security holes you may be able to find, because those test guidelines may not be comprehensive to discover all the vulnerabilities that exist. Okay, so you may have found in your assignments and other resources that sometimes you might have to think about how to go about exploiting or providing security for it. Okay, some background. It's an integral part of software development. So we have seen from a few videos before about secure software development that security gets built into as part of the software development process. Okay, and normally we want to ensure several aspects of the system, including the correctness of the software, performance, reliability, and so forth. And all of that will contribute towards having a secure product. Okay? But things that we also should consider is that when we design our software, that it should be designed such that it's testable, that can easily validate what security requirements it's satisfying, and should also be maintainable as well. But typically, security testing requires a lot of effort, time, and cost to carry out. So it is a good idea that we can minimize what we need to test, and this requires understanding good about the requirements, design, and implementation process, which we already covered in the previous videos. Okay? So when we conduct tests, there are two potential outputs. It's quite binary, really. We got a positive test, which indicates a no problem found. This means either we tested the ones that we know, and those have all passed. But this doesn't really mean that there aren't any defects lurking outside of the test area that we have seen. Okay, so it is good that it has passed all the ones that we have set out to test, but we should always have in the back of our mind that there may be some other aspects of the software that can be exploited. So we need to always prepare for any incident responses and maintenance. And obviously, if we get a negative test result back, that means those items should be addressed accordingly. There are mainly 4 levels of testing, starting from unit testing, integration testing, system testing, and finally the acceptance testing. Okay, and typically you will try to include external testers like pen testers to come and test the systems, and they may be able to pick up some vulnerabilities that you may not have thought about before as well. Okay, so let's have a look at each level of testing here. In unit testing, also may be called module testing, this is where you test individual functionalities of the software that you're developing. Okay, so this will involve things like debuggers, tracers, and typically it's done by programmers who are implementing that particular feature. And ideally, they will do this in a continuous fashion. Okay, so what is the advantage of doing unit testing? And also the disadvantages. You can pause the video and have a think. Assuming we have done that, advantages include that tests are conducted frequently. So this means we can identify issues on the go. So we can address them while we develop. Okay, and also this is the most granular form of test, which provides the highest test coverage. Okay, so we can test every single bits and pieces of functionalities that we have developed. Okay, however, it does come with some disadvantages, something like not many security vulnerabilities can be tested at this layer. Why? because at this particular layer, we are testing individual functionalities of the whole system, right? So we cannot find any vulnerabilities that are arising from dependencies between functionalities and any design flaws. Okay, so it does provide a high test coverage, but it is limited as to what we can test. When we move to integration testing, this is when we can start looking into testing some of the dependencies between those modules. So we can start with a single module and then start adding more connections to those modules and test how those connections are secure or not. Okay, so the advantages include this can test now in the application layer, which means you can actually deploy certain functionalities at application and server, and then we can look into examining whether those functionalities are correctly delivered while in alpha testing mode. Okay? And from this point onwards, we can test many vulnerabilities like injections, authentication flaws, and authorization flaws, etc. But there are some disadvantages like we cannot do this as frequently as the unit test because different parts of the functionalities may be changed over time. Okay, and you need to wait until those changes are completed in order for you to connect to it and then test. And there may be some overhead associated with starting the application server. And still at this point, some vulnerabilities may not be easily testable, like cross-site scripting or URL filtering, things like that, especially if this server is sitting behind the firewall, so it's not actually live on the web. You may working just with like an internal IP address, then we can test some of the other mechanisms that we need to implement on top of that. So we move on to the system testing. So at this stage, you would have implemented most of the functionalities and it's almost ready to be live. Okay. So as part of this testing, you are using real data and real users in this particular test. So advantages include you can test the whole system now, so everything should be functional by this time, and hopefully any flaws that violates the security requirement can be captured and revised. But disadvantages include, again, the overhead of actually testing this, because now you're involving real data and real users, so it can be more time consuming to orchestrate this. Okay? And some vulnerabilities may not easily be testable because you are using a particular set of users, which may not represent the whole population of your potential customers. Okay, and finally, we move on to the acceptance testing. This is where you deliver the product to your client and the client can conduct their own testing. And this is where you can also bring in like external testers. You could bring external testers in previous steps, but this is where usually the pen testers may be hired to provide some security report about what they can find. So this is now where you can start to utilize like user prepared test data and also conduct verification, validation, and auditing. Okay? So advantages include full testing of external APIs. So now your software product is out, and if it's relying on or utilizing external APIs, they all can be tested. And a lot of different tools that conduct security testing can now be used here. And since now it's fully functioning, all the retests that needs to be done after fixing up should be quite easy to do. Okay, but disadvantages include low test coverage, which means you test only what you know, especially pen testers. If you hire pen testers that may not have a comprehensive knowledge on different aspects of the system, they may not cover them fully. And usually the developers are not involved in this particular test, only the client or the pen testers. Okay. And when you conduct these tests, there are two types of testing. Okay. One is white box testing, the other one is black box testing. So you have seen these concepts many times, so the same principle applies here. When we talk about white box testing, we assume you have access to all the source code and understand how things function. So typically you try to pick up any logical flaws. You're trying to examine the logical flaws through the code and pick up any errors that may be arising from them. Whereas in black box testing, you assume you don't have any access to the internal mechanisms and the source code. So what you're trying to test is you have an input with an expected output and see whether these things work or not. So these two testing types can be applied in all of the testing levels that we have covered before. It's depending on what you're trying to capture and examine. But typically, when you're doing unit testing, it's more of white box testing. And as the stage gets later towards the acceptance testing, you're looking towards the black box testing, where external entities are involved in. You don't really want to leak your source code. Okay. So in general, when you're conducting software testing, you want to decide how much security is needed, and those can be derived from your security requirements and security assessment conducted during the first few stages of the software development. Carry out automated testing as well. There are a lot of tools out there that can be used. Test at every stage. You want to ensure that at each stage you can pick up security flaws and fix them as you go. Make a test plan. Without the plan, it is difficult to oversee what kind of testing is necessary at which stages. And all system components should be tested before they get released. Okay? And so when conducting these tests, we should consider two aspects of security testing. First one is testing security mechanisms in system to ensure that their functionality is properly implemented. Okay? So this is examining all the existing security features and mechanisms that you have built into your software and testing whether they are correctly functioning. Okay? And another aspect is perform risk-based security testing. Okay? And this is motivated by understanding and simulating the approach of a likely attacker. So kind of like looking from a pen tester's point of view, where you're presented with a system and you're trying to do some malicious activities to see how you can violate any of the security requirements. And using that report, we can try to address those issues. Okay. Obviously, when we conduct some such assessments, it really depends on how capable the testers are, right? So in terms of pen testers, they do have certifications and guidelines, but obviously everybody have different skill sets and therefore may not necessarily cover critical security flaws that your system may needs to be checked because of different skill sets. Anyway, I will leave that question for you to think about there. Okay. So in addition to testing, there are some other things to consider, things like software vulnerability analysis, secure coding, security assurance, software security maintenance, which we haven't really talked about, and so forth, right? However, these items will not be covered in this unit. And that concludes the testing. So I will see you in the next video. Bye.